Welcome back to this explainer. Okay, so have you ever really stopped to wonder how artificial intelligence actually looks at the visual world around us? I mean, how does a machine take raw, meaningless pixels and turn them into actual perception? Well, today, we're going to completely break down the layered logic of computer vision.
And honestly, this perfectly illustrates the core problem right off the bat. Think about it. When you look at a photo of a dog, your brain instantly goes, hey, that's a dog. You don't even have to think about it. But a machine's reality is just entirely different. When a computer looks at that exact same photo, it doesn't see fur or a snout or a cute little expression. It literally just sees a giant grid of numbers. We're talking millions of them, and absolutely nothing else.
To a computer, a picture is nothing but an enormous spreadsheet of numbers. There's zero inherent meaning there, just values. Every single pixel is simply a number that tells the computer about color and brightness. And since a modern photo contains millions of pixels, well, there's no actual dog hiding in there. So the big question is, how on earth does a machine get from staring at a giant, abstract wall of meaningless numbers to confidently declaring, yep, that's a dog?
The answer is actually one of the most elegant ideas in all of artificial intelligence. It's an architecture called a convolutional neural network. This was the massive breakthrough that finally cracked the code of computer vision. And the key insight here? It's that the network doesn't try to understand the entire image all at once. Instead, it builds its understanding in layers. It starts from the incredibly simple and slowly works its way up to the incredibly complex.
This right here is where the mathematical magic really happens. It's a bottom-up hierarchy. So for step one, the very first layer of the network doesn't look for a dog at all. It just looks for the most basic thing imaginable: edges. Little slivers where light meets dark. Then, step two, the next layer combines those basic edges into slightly bigger shapes. Think corners, curves, or textures. Moving to step three, the layer after that starts assembling those shapes into identifiable parts, like an eye, an ear, or the curve of a snout. And finally, step four brings all those parts together into whole concepts, like a face, a specific breed, or, you guessed it, a dog. Edges become shapes, shapes become parts, and parts become objects. Now you might be thinking, okay, so a human programmer must have manually coded all these specific shapes into the computer, right? Actually, no way. Nobody tells the network that a dog has floppy ears. It discovers all of this entirely on its own. It figures out that certain combinations of edges and shapes add up to dog, purely by studying huge numbers of labeled images. It organically learns this entire hierarchy just by analyzing massive amounts of data until those patterns become crystal clear. And here is the truly beautiful biological twist to all of this. When we actually sit down and compare silicon to biology, it turns out this is essentially how your own brain does it. In human biology, the early parts of your visual cortex respond to very simple edges, while the later, deeper regions handle complex, whole objects and faces. It's exactly like the AI. We have essentially reinvented, in silicon, the exact same layered strategy that evolution already found for sight. So the next time your phone instantly finds every single face in a group photo or perfectly categorizes your pet, just take a second to think about that layered, patient mathematical process happening in the background. It took a massive wall of numbers, found the edges, built them into parts, and assembled a face, successfully turning pure arithmetic into recognition. But, it leaves us with a pretty fascinating question. If just a few layers of math can successfully see a dog, what happens when these networks get thousands of layers deep? Are these machines just mimicking sight, or are they on the verge of developing genuine, human-like understanding? Thanks so much for joining me on this explainer, and we'll catch you next time.